This video is about block time. Here I'm going to go quickly over the principle of the light cone. There's a single x-axis, could be an xy axis with time in that direction, and time moves up like this, and the speed of light here and here in the negative direction are scaled to be 45 degrees. We have Alice at the origin here, and she doesn't move along the x-axis, but in obviously in time there would be difference. She puts a mirror equidistant, two mirrors equidistant, and then she sends a pulse to the mirror. It comes back. She assumes that event A and event B, because they're equidistant and they bounce back at the same time, happened at the same time. Now we have still Alice as the reference frame, staying stationary and moving along the timeline, but Bob is moving in the x direction, so his motions at constant speed is shown there, and he has two equidistant mirrors and he bounces light off them, and Alice says that these two times are different. Bob says, well, they're equidistant, I bounced light off them, they arrived at the same time. I've actually done something simple here, where I take Alice and put two flags equal distances from her, and she sends a messenger, could be at the speed of light. There, touch the pole, come back again, and she says they touched the pole at the same time because they arrive back at the same time, traveling at the same speed and equal distance. Here we take Bob and we put him on wheels, and the carts and wheels, and we move them, and then he sends two messages at the same time, one towards the flag, the other one towards the other flag, and they come back. They also arrive at the same time, but as we'll see from the graph, they're different. I've illustrated a third one here, Carol, where the messengers travel with everything else. In other words, the system is the same, and the messengers go there and back, but Alice will see Carol's messengers traveling at 3 units, because there's 1 unit of time plus 2 units of time. She sees them traveling at 2 units of time, which could be 150% of the speed of light, which is a problem. What is interesting here is that in this, if this was a closed system here or here, what is the speed of light? Does the underlying vacuum field move with Carol? I don't think so. In other words, it's more likely to be this situation where Carol may be moving through space, but the underlying vacuum field is, the speed of light is constrained by the fact that the underlying vacuum field moves, is stationary with regard to the center of the universe. This was the situation with Alice, 10 units of distance, and the messengers moving at 2 units of distance per unit of time, and they go there and back, and they will arrive at 10 units of time each, where Alice is the reference and he's moving along here. The messengers move along here, and what you can see is that gets there quickly and then takes a long time. That takes a long time and then gets there quickly. The net effect is that they both arrive at the same time, and what's interesting is that the speed of light is always measured by going there and back. So if it is slow going one way and faster, or going the other way, it evens out. So there is no way to measure it one way. Now this is what some videos and books claim, is that if you have a supernova, and here's a time axis where this is universal time, someone is born, there's a supernova event, and then they die. If you have two observers, Alice and Bob, and they move in halfway in between, and the light from these events reaches them, they say they happened at the same time. So what they're saying is block time now is that the past, present and future all happen together. My opinion is no. The information travels. Show this here where we have this is cosmic time. There is a point somewhere, which we don't know, that everything's relative to, there's a cosmic reference line, and everything can be said to happen to that. So here we have a fixed time t1 here, and in our flat plane universe here, there's event 1, event 2, event 3, and B1 and B2 are moving together, or we freeze it, everything happens at the same time. Then we take another step, and in the next time t2 we see B1 and B2 collide. Every observer sees B1 hit B2, everyone. There's no, it's because it must be. Now here is just a instantaneous freeze. Everything freezes, and then you take the next step to t4, and this event will cause something there, that will cause something there, and so on. Very difficult for something there to cause something there, but these are local perceptions of events, not physical reality. It's information arrival. This is a simple illustration of reality does not change, but perceptions, especially when information is missing, can be different. So here we have an object. Bob sees it from this side, Alice sees it from this side. Alice sees a square, Bob sees a circle. And whether the object is backlit or even full light, depending on how the object is constructed. The object is a cylinder, but Alice thinks it's a cube because she can't see the other dimensions. Bob thinks it's a sphere because, again, he can only see a circle. It's a simple example of relatively information travels and can be missing the details. If one holds it, if you hold it, you've got information to everything. It's mass. You can turn it around, feel it, and observe, get as much information as possible. Thank you.